Welcome back. This is again continuation of our linear regression, which is correlation and causation. So a quick recap. As we know, y is equal to mx plus, y is equal to mx plus b, where m stands for my slope, b stands for my y-intercept. Slope is simply rise over run. If the line is going up, my slope is positive. Line is going down, my slope is negative. Now, what does that mean if line is going up and line is going down, slope is positive and negative? Like we discussed before, positive slope, x increases, y increases. Negative slope, x increases, y decreases. But how do we interpret this in terms of the slope? So according to, if your slope is positive, then if the slope is positive, then on average, y is expected to increase by m units. If the slope is negative, on average, the y is expected to decrease by m units. That's what it means by the slope. Because as you can see, you rise by the slope. So on the average, you rise so many units. Again, finding the slope is simply rise over the average run, correct? Now, let's go ahead, take a look. Remember, positive slope, x increase, y increase. Negative slope, x increase, y decrease. Which of the following data set or plots could have a regression line with a negative slope? With a negative slope. The number of hours you will be awake as a function of number of cups of coffee. So it has to be opposite. Negative is if x is increasing, y is decreasing. So if I drink more coffee, then I will be awake. Both of them are increasing simultaneously. So definitely not this. The number of hours you will sleep as a function of number of cups of coffee you drink. It's the same thing. The number of hours you will sleep as a function of number of cups of coffee you drink. The more cups of coffee I drink, the less sleep I have. So this is negative. So it's right. Um, the amount of money you spent per day on coffee as a function of number of times you go to the coffee shop. Let's say this is my coffee cup. If I go once, I pay $2. If I go twice, I pay $4. If I go 3 times, I pay $3. So as I'm going, my payment is increasing. The more I go, the more I pay. So that's not positive. See what I'm doing? I'm trying to put myself in the situation and think what's happening. The number of minutes you will wait to pick up coffee as a function of number of people who are working behind the coffee counter. So if there are more number of people, that means I'll have less time to wait, right? Think about it. If you go to a store and you only have one cashier, what do? You always look around and see if anybody's coming. Why? Automatically, you know if you have more, the time will be less. So more people, less time. Opposite. So it's negative slope. Fair enough? Let's look at the next one. A research experiment started in 2002. So the starting point is 2002. So the zero is 2002. You start at zero, but in this case, you start in 2002. That studied the number of sea turtles tagged by scientists in a given year, where X is the number of years since 2002. The least square regression line, or the line of best fit, is given by, so this is the line of best fit. So you have 917,234 minus 444x. As soon as I see the slope, it's telling me that on the average, the sea turtles are the number of sea turtles are definitely going down, right? But what did they ask us to do? They ask us to interpret the y-intercept. So what I'm going to do is I'm going to simply draw. Can you see this? Yeah. I'm going to draw this. So this is 2002. I have 917, right? The slope is going down. So it's negative, so that means the slope is going down. So sea turtles are decreasing. Why did I put it over there? That's not my, so let me redo it. Right, so my, 917, negative. Okay, so it's going down. So what are they asking me? Interpret the y-intercept for the least square regression line. Remember, in 2002, so you start at 2002. So when you started doing the research in 2002, how many turtles did you have? 917234. So your y-intercept is telling you when your x is 0, that means when you started right away, that's how many turtles you had. So the prediction number of sea turtles tagged by the scientist in the year 0. There's no year 0, that's a no-no. The number of sea turtles tagged by the scientist in the year 2000. Well, he said he started in 2002. The number of predicted sea turtles tagged by the scientist in 2002 is 9137. The y-intercept should not be interpreted. No, but we will see a case where the y-intercept should not be interpreted. Sometimes you do have a y-intercept, but that's not reasonable. Let's go ahead and take a look. The oops. The scattered plot below shows data for average cost of high-end computer in the year X since 2000. The least square regression, the line of best fit, is given by this equation. As you can see, the cost of the computer is increasing on the average. So this plot gives you the average cost of the high-end computer. But remember what the slope is. The slope is the average of the average value, the y increases. So your value already is an average. So your slope is the average of the average. Confusing? Remember, the slope gives you the average. But this particular graph is a graph of the average. So the slope gives you the average of the average. Now let's go ahead and take a look. So this is the number of years: 4, 6, 8, 10, 12. As you can see, they started at 6 because that's where the first dot is. So my range is 6 to, let's say, this particular value. Anything before or anything after is unreasonable and doesn't make any sense. Now let's go ahead and take a look. They're asking us to interpret the slope. As you see, the slope is positive, it's going up. So on average, the average cost of the computer increases by 314. So let's go ahead and see if that is one of the options. The average cost of the high-end computer is predicted to decrease. No, it's a positive slope, so it increases. On the average cost of high-end computer predicted to increase. Yes. So remember, the slope gives me the average, but this graph is the graph of average. So the slope gives me the average of the average. So that should be my correct answer. And it's not just one average. And on the average cost of high-end computer is 1677. No, that's not the slope at all. Now let's go ahead and see the next one. What about the y-intercept? So what does y-intercept mean? So I'm gonna, when I extend this graph, let me erase this. Tup, 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 tup. So when I extend this graph is going beyond the range. So you see that my y-intercept is somewhere here. That's not in the range of my 6 and 12. So it's way below it. So finding the y-intercept is not reasonable because it's not in the range. So let's go ahead and see what happens to the next problem. Interpret the y-intercept. The predicted cost of the computer in the year 0. There's no year 0. The predicted cost of the computer in the year 2000. No, 314 is the slope. It's not the intercept. The predicted cost of the computer in the year 2000 is positive. No, it definitely says negative. If you scroll up, you will see it's negative. Let me scroll this down. You see it's negative, not positive. So even this option is wrong. My only option is the y-intercept should not be interpreted. Why? Because when I go all the way down, y-intercept is when x is 0. But what are my values? What is my x range? My range is from 6 to 12. 0 is outside, so it's unreasonable. Fair enough? Now let's go ahead and take a look at the last topic of the course. It is understanding the difference between causation and correlation. Causation is something that forces something to happen because something happened already. Like causation is when one action causes another action to occur. For example, smoking causes lung cancer, running causes weight loss. Correlation is a relationship between these two actions when one action does not necessarily cause the other one. For example, smoking and alcoholism are correlated. In the smokers usually tend to drink alcohol, but smoking does cause lung cancer, but smoking does not cause alcoholism. See the difference? There is a relationship, but it's not causing it. Okay, so I want you all to go ahead and read this one very, very carefully. Statistical variables can be correlated when two variables are correlated, a change in one variable associated with a change in the other. Like we say, when x is changing, I'm trying to see how y is changing. So one is changing, what happens to the y? I'm trying to see how both of them, the change in one relates to the change in the other, not causing one another. Okay, all right. Correlation is easier to prove since it's a relationship based on the data values numerically measured, so it's much easier to prove. Causation will cause a relationship between the dependent and independent variables, but it's much harder to prove because it